What are we going to do?
How are we going to wash dishes without a sponge?
I know! We can forage for a sponge!
Wait a second. Is that a tin 2 chloride book?
I can't believe my eyes!
Look at that, folks! Tin 2 chloride, straight from nature.
Straight out of the ground, some zinc!
Now that we have our dishwashing clothes on, let's make sponges.
Alright, so first I'm going to get our mossy zinc here in this beaker, and I'm going to pour it to cover the bottom of our camping beaker. I guess I'll use the spout. And we pick some small pieces so that it reacts more quickly.
Now we're going to pour 200 milliliters of tin 2 chloride hydrochloric acid.
It's 0.5 molar as well. There we go.
200 milliliters. Now we will wait until it gets mossy and rises to the surface. So, as you can see, there are many bubbles coming up from the zinc, which will eventually make it float because the tin 2 chloride solution has hydrochloric acid in it, which reacts with the zinc. In this reaction, producing H2 gas, which makes the density of the sponge decrease, and eventually it will float. This reaction happens in a single replacement reaction, creating this gas you see rising to the top.
As you can see, we have some beautiful tin crystals forming at the bottom of this beaker. That's the result from another single replacement reaction, which we have demonstrated up here. That's the reaction of our solid zinc, which we poured at the bottom of the beaker, reacting in our clear solution of tin 2 chloride. And the zinc replaces the tin, forming zinc, chloride, and tin, which are the crystals we see at the bottom. We'll explain more what a single replacement reaction means in a minute.
We're going to demonstrate what a single replacement reaction looks like using the letters A, B, and C. In this reaction, A replaces B. Here is what it looks like when applied to our reaction. As you can see, the zinc replaces the tin like A replaces B. B was bonded to C, but A is more reactive than B, so it replaces it when the reaction occurs. Why is this, you ask? This is because of something called an activity series. An activity series is a ranking of elements from most reactive to least reactive. Some of the factors that contribute to this ranking system include the number of protons in the nucleus. The more protons there are, the stronger the pull is on the outer electrons, making it harder for the electrons to be lost and harder for the atom to react. Another factor is the number of electron rings there are in the atom. This makes the pull of the protons weaker on the outermost electrons and easier for them to be lost. This would put the atom on the lower side of the activity series. As you can see here, zinc is more reactive than tin, therefore determining that it will replace tin in this reaction. Now we have our finished sponge. Time to do the dishes.
Wow!